Right, this is part 2 of 10.4. Let's recall we have the polar coordinates. It's a new way to locate points rather than using the x, y coordinates. We use r and theta coordinates. So any point in the plane now will be represented by an order pair where the first number will be the directed distance from the pole, and then the second number is the angle it makes with the positive x-axis, right? So we get to the polar graph here, as I explained in the rectangular coordinate system. We have the equations involving x and y. Sometimes x is missing, sometimes y is missing, so those are special cases. Um, Similar to the rectangular coordinate system, we have equations that involve r and theta, right? So r is like y and then theta is like an x. So what happened is when you have r and theta like this, then if you want to graph, you're going to plot points, okay? So the same way we do, we're going to look at number 3 first, okay? So if you want to, okay, grab these equations, instead of doing x and y, we're doing theta and r, right? So he's in theta, he's in r. So you plug in the values for theta, we pick some like 0, and then pi half, and then pi fourth, and pi, etc. Then you plug in your calculator to get the r values, okay? So when you got that, and then you're going to have the point r theta, you plot them, and you grab it by connecting those dots. Now, as you can see, it's not very easy to do with the polar equation, because when you do all of these, it's going to come out with some nasty numbers, or when you plot here, connecting dot, it's very hard to do by hand, okay? Unless we have some special case, like if you look at number one is a special case where it's easy to do because theta is missing, right? So if you plug in 0, or you plug in pi fourth, or you plug in pi half, or you plug in pi, notice that r is a constant, it's 5. So no matter what you have for theta, it's 5, r is 5, 5, 5. So then you end up with the point, by the way, r comes first, this would be 5, 0, 5, pi fourth, pi, 5, pi half, and 5 pi. Right, so we go back to the polar graph we have here. If you're going to grab them, then you're going to grab 5, 0, 5, pi fourth. And notice these are the angles, okay? So that means if you're starting at the pole, you're facing the 0, which is this line, this ray, or you're facing pi fourth, or using facing pi half, or using facing pi, or in all directions, the r is 5. So where are they? So 1, 2, 3, 1, 2, 3, 4. So you have 5 here. 1, 2, 3, 4. So that's a 5 here. This angle, you have 5. This angle is a 5. It's 5. So you see that when you connect all of them, what do you see? You actually end up with a circle. So the graph of article 5 turned out just to be a circle. Where's the center? Well, at the pole. At the pole. And what's the radius? Well, obviously radius r is 5, right? So again, that one is a special case, so we can actually do it very easily without going through the math here. Likewise, for number 2, this is also a special case. Theta is pi fourth. So in this scenario, your theta is pi fourth, and pi fourth doesn't change. R is missing, so basically R could be anything. It could be 0, it could be 1, it could be 2. So now you're going to have a lot of points where the first the R could be anything. Look at this time, big bracket, right? So the R could be 0, or could be 1, could be 2, could be -2. Yet the theta is constant. Okay, constant, so it doesn't change. So if you plot them, what does it look like? Okay, pi fourth is this line right here. There's 45 degrees. Now notice that R is could be anything, right? R is 1 right here, 2 is there, 3 is there, 4 and 5. 0 is here, -1, -2, -3, -4. So if you connect all those points, you see that will end up with this line. Okay, the 45-degree line is at pi fourth. Okay, so this turned out to be a line. 45 called 45 degrees line. Okay. Now again, these are new because these equations are new involving r and theta. Oftentimes in algebra 3, I have no idea what this is going to look like. So the best way to do is we want to convert this back to the familiar type equation. Okay, we call it the rectangular equations. So I want to confirm the graph circle and the line here by converting to a rectangular equations. So that means I want to turn the equation into x and y rather than r and theta. Now to do so, we will be using these four. Okay, that I have up there, but I just copy it down here. These are the four formula that help us convert back and forth between the rectangular and the polar equations. For example, looking at r equal 5. Okay, so r equal 5. Okay, so if you're going to convert it back to rectangular equation, okay, so I have number 1 is r is 5, right? Notice that which equations here that involve the r. Remember, our goal is convert it back to x and y. Okay, I just need x and y, no r, no theta. So which one to use? Well, that one has r, but it has theta, which I don't want, and r and theta I don't want. This one has r and it has x and y, so that's what I want. Because I want to convert r to theta, r to x and y. And this tells us the relationship between r and x, y. But I have r equal 5, here I have r squared. So that suggests I'm going to square both sides first. Okay, r squared equal 25. Okay, square both sides. So that have r squared and r squared is the same as x squared plus y squared. So I replace r squared with x squared plus y squared. And you see now I've obtained a new equations. And this equation contains x and y only. This is the rectangular equations. Now from here, can you tell what the graph look like? Yes, right? So this is standard form of the equation of a circle. Centered 0, 0, and radius r squared, so r is 5, which is what we got here. All right, so let's look at number 2. When theta equal pi fourth, okay, so that's our equations. Once again, I want to convert to equation with x and y. So I need to find the relationship between theta and xy. Theta and xy, which one? See, this one, theta and xy. Okay, so I'm using theta, tangent theta equal y over x. Now I only have theta, I don't have tangent, so I'm going to take tangent on both sides. So tangent of theta is equal to tangent of pi over 4. And tangent of theta by this formula, that's equivalent to y over x. And the tangent of pi 4, tangent of pi 4 is 1. If you multiply both sides by x, you y equal 1x. And we obtain this little nice equations in rectangular form. Do you know what the graph of y equal x look like? Yes, right at the 45-degree line through the origin, right? Through the origin, right? So that is how we do it. Now, looking at number 3, so that one, again, I have no clue what's the graph look like yet, okay? By the way, if you want to use graphing calculator to graph it, then this is what gonna do. You're gonna go to the mode. You hit the mode button on your calculator, and you should see down on the 4th line, it has 4 options. The first one is functions. The second one you're gonna see it's PAR, it's parametric equations. The third one is the one that we'll be using, pole. That is polar equations. And then there's a 4th one here, it's a sequence. Okay, so we will be using number 3 here. Okay, you choose pole. When you want to choose pole, then you will have, and then you go to the y equal. Okay, you hit the y equal functions. And if you hit the y equal functions, this time, instead of, you usually see like y1 equal, y2 equal, right? And then you enter the formula when you graph, it changed, right? So it's no longer y1, y2, that's rectangular equations, right? Then you're gonna see an R1, an R2, and R3. And then he's gonna enter the formula. For example, you can enter, you put the 5 there, and then you can put the pi4 there. And then if you want to graph this one, 5 cosecant, you can add 5 times cosecant. But we don't have cosecant, so you have to rewrite that as 5 over cosecant is the reciprocal of sine, right? So that's the same as phi over sine theta. So what you have to do is do phi, enter phi divided by sine theta, right? So theta, when you enter in the calculator, you just hit the X button. It will automatically change to theta when we are in polar equation mode, right? So once you're done the graphing, if you want to go back to rectangular mode, make sure you hit mode and go back and highlight the functions, and we're going to go back to the y equal instead of r equal, right? So you can try that and graph to see what's the graph of this r equal 5 cosecant theta look like. Now, of course, a better way to do is we can convert it to rectangular equations, and we can tell from there. Like in this case, what do we do, right? So our r equal 5 cosecant or 5 over sine theta. Right, so naturally when I see this, I will rather find sine, and I really don't like the sine the bottoms. We multiply both sides by the denominator, we end up with r times sine theta equal 5. And from here you can see which one I'm going to use. You see that our sine is the same as y, so you have y equal 5. Well, it turns out this graph r equal 5 cosecant theta is equivalent to y equal 5 in rectangular equation, and so that must be a horizontal line. Okay, you can check on calculator, the graphing calculator, that is a horizontal line. Right, so the next topic key is, would you be able to convert from polar equations to rectangular equations, or from rectangular equation back to the polar equation? Okay, so let's do the left hand side first. Convert to rectangular form. Now, number one is really that in this example here. So basically, I'm done, right? So the r equal 5 cosecant theta is equivalent to y equal 5, right? So the y equal 5 in the rectangular form. Now look at number two. Look at number two here. R equal 3 sine theta. R equal 3 sine theta. So how are we going to convert to the rectangular form? Again, you'll be using these four. These four. Now, you're going to pick the one that works. So which one do we choose? It's actually easy though. Look at the equations here. This equation has sine theta. So that means you have to pick the one with log sine theta, which is this. But in order to use this formula, you need r times sine theta. I have sine theta, and I don't have r times sine. So all you need to do is multiply r on both sides. Okay, time r on both sides. Why? Because when you do so, that becomes r squared, and that becomes 3r sine theta. And that is where you want to apply this formula. The r sine theta is in fact y. At the same time, the r squared on the left nicely equivalent or turn into an x squared plus y squared. Right? So now I have the rectangular equations as x squared plus y squared equal 3y. Now, basically I'm done, but since this is second degree equation, so that means it is conic. So our goal to convert to rectangular form is to be able to identify the graph of these equations. If you leave it that way, you cannot tell what's the graph of these equations. So in order to convert it, rewrite it, we're gonna need to complete the square by bringing the 3y to the left hand side. So that's subtracting 3y. That's equal. That's in 0, right? Now, since I bring it over to the right hand side, notice that x squared doesn't have an x term, that has the y term. So I could decide what to add here to make a perfect square trinomial. Taking half of 3, so it's 3/2, and you square, it's 9/4. So I will add 9/4 on both sides, and that turns into a perfect square trinomial. That is x squared plus y minus 3/2 quantity square equal 9/4. Now from here, not sure if you're able to identify it now. What is the graph of this equations? This is a circle, isn't it? So that is a circle. Center. Where's the center? It's 0, 3/2. And what's the radius? R. Right, this side is r squared, so r is 3/2. So now I have a nice equations, right? So that is equivalent to x squared plus y minus 3/2 square equal 3/2, and therefore that is a circle. Okay. Now let's look at the next one, number 3 here. Number 3, we have cotangent and cosecant. And we want to convert to, again, rectangular form. Again, the first step when you see this is cotangent and cosecant. You see that over here don't have cotangent and cosecant, right? One of these 4 formula. So you're going to rewrite it. So we're going to introduce the cosine and the sine. So that is cosine over sine. The cosecant is 1 over sine theta. Right? So now we have cosine sine. The next step is I want to rewrite by getting rid of denominators. You multiply both sides by sine times sine. Right? So we have, if you times sine for both sides, you're going to have r times sine theta times another side of theta equal, then cancel the 2 signs. So you're left with cosine of theta times 1. Okay. Now, again, which formula to use? You can see there's a sine, there's a cosine, so it must be these 2. In fact, the first one here, it's this one is already, you see the r sine, right? R sine, that one become a y. Now the problem is these 2, the cosine that's left on the right, does not have the r. So what should we do? Well, standard techniques here. If you want it, just multiply both sides by the quantity we want. So what if I times r on both sides? Then I have r on the right as needed. R cosine is x. Then I have an r times sine, that is y. So now I have y times y equal x. And that is what? That's really a y squared equal x. Right, so do we know this? Yes, that's not a conics. So that is the parabola, right? So the parabola is open to the right instead of open up. All right, so again, that's equivalent to a y squared equal x, and we have a parabola open to the right. Okay. Parabola. Okay. Right, so that's how we do convert from rectangular, polar to rectangular equations. Now, the other way around, we would do it pretty similar. Okay, it's pretty similar. If you're gonna convert from okay, so zoom out a bit. Right, so now I want to convert to polar form, right? So look at the equations A here. Okay, so from the equations A, we have x squared plus y minus 3 squared equal 9. Now this time again, normally it's the way when we convert to polar form is using the first 2 easily. Why? Because when you see the x and you replace with r cosine, the y you replace with r sine, and pretty much we're done. Okay. Let me look at the b here. You can see that it's really quick. B here, right? Because you have x times y equals 7. Since I convert to the r and theta, then I just replace x with r cosine. Okay, so all you do is replace the x here with r cosine theta time, and then the y is r sine theta. Right, so that one and that one, and it's equal to 7. You see now everything in terms of r and theta. But usually the one more step we do is we try to solve for r's the same way as we try to solve for y, if we can. But sometimes, like in this, when you x squared y squared, just leave it that way. But otherwise, we can usually solve for y. And here we often solve for x, solve for r. But in this case, you have r times r is really r squared, right? So it's r squared. Then you divide by cosine and sine, so it can be 7 over cosine theta times sine theta, right? And because it's a square, we just leave it like that. Okay, so then I have, this is the polar equations. Okay, the polar equations. Now, you can leave the answer like that, but if you want to make it look a bit nicer, nicer mean if you don't like the fraction, then we can use some trick identities here to rewrite it. R squared equals 7 times. This is 1 over cosine, right? 1 over cosine is equivalent to secant. So that's secant theta. And then that's 1 over sine is cosecant. So cosecant theta. All right, that looks a bit neat. You can live that way or that way. Either way is fine. Same thing for C. You see that C, he just replace x with r cosine and y with r sine. So it's not it's pretty straightforward. X squared equal negative 4y, and x again is r cosine. So replace x with r cosine and y with r sine theta. Then the equation become r squared equal negative 4 times r sine theta. And that would be an r squared cosine squared equal negative 4r sine theta. Right, so I guess one more step here, we're trying to solve for r, but it looks like we have on the left, on the right, you time on both sides. So we're left with r equal cosine squared. And now solving for r. Okay, solving for r. Then I just need to divide. So I have negative 4 sine of theta divided by the cosine square. And I have the r by itself, right? So that is the equations that we need. Now that's a polar equation, right? Once again, if you just don't like the fraction where it looks a bit complicated, you can use trick identity to rewrite. And it's negative 4. I can rewrite that as c sine over cosine. That's the same as tangent of theta. And then you're left with another cosine at the bottom, and 1 over cosine is secant theta. So it's a bit neat, okay? Again, but it's not required. Well, I just realized that I put it in the wrong spot. So let me rewrite it. Actually, this is c is negative 4 tangent theta and secant theta. So that is for C. And the answer here is actually the B. That's r squared equal 7 secant theta and cosecant theta. Since I skipped the A. Now, A you could do the very same way, but it just because I don't want r sine theta replacing squaring, that's a bit complicated or a bit tedious. So it might be wise to just leave it for now, and you just FOIL the binomial first. So 1 minus 3 squared is 1 minus 3 times 1 minus 3, or y squared minus 6y plus 9 after you FOIL and combine the like terms. Right, so you see that looks a bit better after you FOIL. Now we're going to replace. Now normally I use x is r cosine, y is r sine, but there is a better formula in this case. R squared is x squared plus y squared. You see this one, right? So that is just r squared. So that's make it nice. And now the y is to replace it with r sine theta. Okay. And now we still have a minus 6 r sine theta. 9, subtract 9, both sides become 0. So you have this. Again, you're solving for r. If you add on both sides, r sine, 6r sine, we have r squared equals 6 times r sine theta. And eventually I divide by r on both sides. Then I arrive at the final answer r equals 6 sine theta. Okay, so that'll be our answer for that one. R equals 6 sine theta. All right. Now, the next slide here is just a polar graph. So just want to show you that the polar equation is very useful in art. Lots of cases where the graph is very symmetric and looks nice, but cannot be described using a rectangular equation. You can see r equal 2 cosine 2 theta. Its graph will be look like a, this is called the 4-leaf rose curve. It's look like 4 petal rose. It's very nice. Okay. Or this equation, r equal 2 sine of 2.15 theta. If you graph this, it looked like a very fancy artwork. Look like a super flowers. Okay. Again, in no way can we use the rectangular equations to describe it. Number 3, I didn't do it, but if you graph it in calculator, it should end up with a heart-shaped graph. It's pretty nice. Now, the final part of these sections is the derivative. So let's recall the derivative. How do we find the derivative in polar form? Okay. Now, one thing is, don't forget that I could mention that many times. The 4 formula up here is very important, especially the first 2. X is r cosine and y equal r sine. Okay, so here recall these 2 formula here. Okay, these 2 formula. X is r cosine, y equal r sine. When we take a derivative, keep in mind that we always doing dy dx. That's the change of y with respect to x. Now, if you're looking at these 2, we have what the x is the same as r times cosine of theta, and y is r times sine of theta. Okay, so we could express x and y in terms of theta. That is like the parametric equations. So when you do the parametric equations, remember how do we find the derivative with respect to x, dy dx? We're going to take the derivative of the y and take derivative of x, which is here, derivative of y over derivative of x with theta instead of t as a parameter. And then the y again is r sine, and then the x is r cosine. So you end up taking the derivative here, divided by the derivative here. Now, one thing you should keep in mind is that r is a function of theta. Look at this. R 6 theta, that's this, right? R is negative 14 to the secant theta. So R is the function of theta. So when you take a derivative of R times sine, this is actually the product. So you have to use the product rule there. So that's the derivative of R times sine plus derivative sine is cosine times R. Same thing for the bottom. You use product rules here. Now, some students try and memorize this formula. When you take a derivative, you could, but I often don't memorize this formula. Rather, you're gonna replace R with replace x with R cosine and y with R sine, and then take a derivative using the product rule directly, rather than memorizing this formula. Let me show you an example of what I mean. Find all the horizontal tangent to the curve. I'm going to skip the detail here, but I'm going to focus on the derivative. So how do we find the derivative to y dx in the parametric form, right? So the goal is to find the derivative y with respect to x. But what is x and what is y, right? So we don't have x and y yet. We only have r, given r is 1 minus cosine theta. But again, don't forget r with x is always r times cosine. Y is r times sine. Then r again is given. R is 1 minus cosine. So that's 1 minus cosine theta times cosine theta. And then here is 1 minus cosine theta times sine theta. Okay. Now, can I take a derivative from parametric equations? I take a derivative of the y, and then take a derivative of the x. But again, be aware that we have a very a bit tedious derivative here, because taking a derivative of the y here involving a product, see that and that. So you have to take the derivative first times the second plus the second times the first using the product rule. Right, so what's the derivative of 1 minus cosine? Now derivative 1 is 0, derivative cosine is negative sine. With the negative, it turns into a sine theta. Right, so derivative of this first part is sine times the second is the sine theta plus derivative sine is cosine theta times the first is 1 minus cosine theta. The bottom, you're taking derivative of x. Same thing, derivative first, the thing we did is really sine of theta times the second is cosine of theta plus derivative cosine, and derivative cosine is negative sine times the 1 minus cosine theta. Okay. Right, so that's how we got the derivative. Okay. Now, of course, from here we could simplify more. Right, we could multiply. Okay, so I can multiply things out. Sine times sine gives us sine square. Cosine times negative cosine, I think that negative cosine square cosine times 1 is cosine, switched order a bit. Right, so we have sine square minus cosine square and plus cosine theta. At the bottom, you have sine cosine. I have negative sine. And there's another sine negative times negative positive. So I have another sine times cosine. So you combine it through 2 sine theta times cosine theta and minus sine theta. Okay. Now don't forget that once you take a derivative, all this 1/2 is really the slope formula. If you ask to find the horizontal tangent, for example, when this horizontal tangent takes place, horizontal tangent takes place when, or I should say when the slope is what? Slope is 0, right? So that means the slope must be 0, and you're going to set that equals 0 and solve for theta. Okay, so when you set that equal to 0, the numerator got to be 0. So that boils down to solving the equation sine squared theta minus cosine squared theta plus cosine theta equals 0. So here's a quick review of the solving trig equations. See, we have the trig equations here. If you want to solve the trig equations, keep in mind that what you're trying to do is you want to write everything in terms of one unique functions. So what I mean here is, you see there's a cosine, there's a cosine, there's a sine. So since I have 2 cosines and cosine in 2 places, so it makes sense to rewrite the sine squared in terms of the cosine as well. And sine squared by the trig identity is 1 minus cosine squared. Okay, so again, we can convert everything to only one type of trig function, that's cosine. So let's re-simplify bits negative. So you have 1 minus 2 cosine squared theta plus cosine of theta equals 0. I have the negative leading coefficient here, so if I time -1, and that become a 2 cosine squared theta, and that become a negative cosine theta, and that become a -1, so put it here, -1 equals 0. Now you can see it become a quadratic equations in form, right? If you let x be cosine, then you do end up with a quadratics. I can do it directly by factoring. In cosine squared must be 2 cosine times cosine. And then a -1, it has to be 1 times 1, or -1 times 1. Which way? I think you should have -1 here, +1 there. So as you multiply, you have -2 plus 1, you got negative, right? So when you solve, you should have cosine of theta is equal to -1/2, and the cosine theta is equal to 1. So you have 2 possibilities. And then from here, you have to recall that theta, cosine of what is 1, right? Cosine of 0 is 1. Normally, we only consider from 0 to pi only one cycle, although we can go further. I'll use parentheses from 0 to pi. And then the theta here, so cosine what is 1/2, cosine of what is positive 1/2 first, right? So cosine of 60 degree will give us 1/2, and 60 degrees pi third. So what I have is cosine of pi third is 1/2. Then to get the negative, you need to get to the second and third quadrants. So it will be 2 pi over 3 and 4 pi over 3, right? So these are places where you can have the slope be 0. All right, so finish the 10.4.